this video we're going to look at the real number system. So first, let's just talk about what is a real number. And then at the end, we'll actually map this out. We'll draw a map that will help you with, I guess, the memorizing, some of that stuff. So let's just start with real numbers first. So a real number. Now, typically this gets an abbreviation and it's just an R. Okay, so if we were to classify this and we didn't want to write out real number, we would just write R, and that would stand for real number. Okay, so a real number is essentially any number that we're going to come across. Okay, so we could say 2 is a real number. We could say pi is a real number. We could say the square root of 45 is a real number. Basically anything that we see that is, I don't know, that is an actual number, that's a real number. It can be a decimal, it can be a fraction, it can be anything. All right. So then real numbers actually branch off, and I'll go ahead and make this mapping type of analogy, but at the end we'll do one big one. So this actually splits into two directions. Okay, so it goes over here and then it splits over here. Okay, it's like a fork in the road. Basically, from real numbers, we branch off into two different directions. We get into irrational numbers, so irrational, and then we get over here into rational numbers. Okay, so now let's talk about what irrational numbers are. And I'm actually going to clear all this just so we can get a better look. But if you want to, just draw this little map and write some of this definition stuff under rational and irrational. I think it's probably the easiest way. I just have a hard time doing it on here, so let me clean this up a little bit. All right, let's stick with irrational, okay? So an irrational number. Now, there's a couple things to note with irrational. The first one, I'm just going to write down several different key parts, so you can organize this any way you want. So the first thing, they will never be fractions. So a fraction's never irrational, so never a fraction. Okay, that's the first part. If you see a fraction, it's automatically not irrational. Okay, 2, they're going to be decimals. Now, they are decimals that specifically never end. Okay, so they just, you may hear non-terminating. I think never ends probably a little bit more clear. So they never end. Basically, I could say, well, pi is a good example because pi is 3.14 and then it keeps going and going and going and going. Okay, so pi is a good example of an irrational number or a decimal that never ends. Okay, let's go back a little. Let's do, or make one more note. It's also going to be a decimal with no repeating. So we'll just say no repetition. And I'll show you what that looks like. So no repetition. I hope that's how you spell repetition. No, that's not how you spell repetition. Repetition? Question mark? I don't know. However you spell repetition. We'll say no repeating because I can't spell. That's why I have a math degree, not an English degree. All right. So no repeating. That would be an example of, occasionally you'll see this. You may have already seen this. 0.5 and it will have this little bar over it. That means that is a repeating decimal. So automatically that can't be irrational. Or you may just see like 5, 5, 5, 5, and in the calculator that's how it will look. And if that happens, automatically it is not irrational. Okay, so decimals will never end, but they will also not repeat. Okay, so no repetition, no ending. All right, then the third one I want to make a note of. This one's an easy example of when, or a easy case to automatically say irrational. If you have a square root, but inside that square root is not a perfect square. I'll give you some examples. So any non-perfect square that's under a radical or under a square root automatically is irrational. Like I'll give you some examples. The square root of 20. 20 is not a perfect square. There's not two numbers that multiply to give you 20 and those two numbers are the same. Like, here's an example of a perfect square. We can do the square root of 16, that's just 4. So that's how you know that 20 is not a perfect square, because if I do the square root of 20, what is that? I don't know, because there's no square root of 20. Because 20 is not a perfect square. So if you have a square root of a non-perfect square, automatically that's irrational. Okay? And actually, I forgot to do this at the beginning. The abbreviation for irrational is I, which, pretty obvious, irrational I. All right, so now let's go back. Let me give you another one. Let's say I gave you the square root of, I don't know, 101. That's not a perfect square. 101 is not a perfect square. You can't multiply the same number twice to get 101, so automatically that's irrational. Okay, so that's an easy trick to know if a square root is irrational. Like, I'll show you one that is actually not irrational. Once again, let's say I gave you the square root of 49. 49 is a perfect square. That's just 7 times 7. So the square root of 49 is 7, so that does not count. Okay, that would be technically a lot of things, but we'll talk about those in a second. So those are the big tricks, or the big main points for irrational numbers. So now let's go to rational numbers. And rational numbers actually branches out into multiple, I guess it goes into multiple different branches. That's a better way to describe it. But first we start with rational. Okay, so rational. And I'll give you the abbreviation for that, or the letter for that. It's going to be a Q. Now, I'll be honest with you. I should probably know this. I have no idea why we use the letter Q. I mean, I know we need a different letter because we've already used R for real, but I have no idea who came up with Q. Maybe I should, so maybe you could look that up to give yourself more knowledge than I have. So let's go over this. So a few key points here. First of all fractions are rational. If you see a fraction, automatically it is rational. Okay? It also can be a decimal. Like, maybe you put it in the calculator and it gives you a decimal, something gives you a decimal, or maybe the problem gives you a decimal. But these decimals are going to end, so they'll actually end, and they can also, we'll say and or. No, let's just say or, because and wouldn't make sense here. So they end, and they can have repetition, which I won't try to spell that again. We'll just say repeating. So like those examples I talked about earlier. Earlier I said 0.5 with a bar over it, that means repeating. Automatically, if we want to classify that, we'd say Q for rational, because it's repeating a repeating decimal. Also, let's look at let's just say 0.5, but there's no repeating. That decimal ends. Okay, that's an ending decimal. It doesn't keep going and expand into a bunch of numbers like pi. It doesn't keep going, so it ends. Therefore, we would just say, if we want to classify this, we'd say Q for rational. Also, one more example. Let's say I gave you a fraction, I don't know. Let's do 12. No, let's do an easier one. Let's just say 3 over 5. Automatically, since that's a fraction, we would say Q, it's rational. Okay? Also, once again, any square root that you can do the square root of, that's automatically rational. Like if I do the square root of 16, that's actually 4. So 4 is the number I want to look at. And 4, technically, any whole number is rational, because I could write this as 4 over 1. So automatically, that's rational. Okay? So rational is a little bit easier, I think. So now let's go back to making our mapping type setup so that you can actually see what we've done thus far. Okay? So first we started with real. We said that real, the abbreviation is R, and then we said this branches out into 2 different directions. Okay? Now, on one side, we have irrational. I'll just write that as I. And then on the other side, we have rational. I'll just write that as Q. Now, irrational doesn't have anything else. Okay? If something's irrational, it's only irrational. But if something is, I may have said this backwards. If something is irrational, it's only irrational. If something is rational, it can actually be more than just rational. It branches off into 3 different levels. Okay, and this is a terrible drawing, but just for now, I want to give you a quick setup. All right, so now the first example or the first subset of rational would be integers. Okay, integers, we use z to describe that. The next one that's a subset of all that would be whole numbers, and we're going to use whole numbers. We're going to use w for that. And then the last one is natural numbers, and we're going to use n for that. All right, so rational breaks off into 3 subsets, which are integers, whole numbers, natural numbers. Okay, so let's talk about those in more detail. And these will actually be some of the easier ones. So let's start with integers first. So integers, once again, we use z for the abbreviation for integers. And integers actually are any whole number that's positive and negative. So positive and negative whole numbers. And we know what a whole number is, right? It's just a, basically it's anything that has a denominator 1. Okay, so positive and negative whole numbers. You can also write denominator is 1, like 4, or -4, or 5, -5. All those are integers, because once again, if you wrote those as fractions, you just say the denominator is 1. So if you want to, you can make yourself a note and say anything from, let's just start at -2. We'll say -2, -1, 0, 1, 2, 3, and so on. Okay, so anything from, I don't know, -1 billion to +1 billion. As long as it's a whole number, those fit into the category of integers. Now, within integers, it also gets even smaller. So next we have whole numbers. And whole numbers are actually, let's write it all out. Whole, that is not what I want. I don't know what the heck I'm doing. Okay, there we go. Whole numbers. I'll actually write out numbers. All right, so whole numbers, those are going to be 0, 1, 2, 3, and so on. So essentially they're just 0 and positive, and they will also only have the denominator 1. So no fractions that we can actually see. So denominator would be 1. So no fractions we can actually see. So like if I gave you 105, technically that's a whole number. Now, technically it's also an integer, but we'll do some of that at the end. So once again, a whole number, you just leave out the negatives, but you still leave in 0. Okay? So you go from 0 to 1 billion, but it's only the positive numbers, and you're also going to leave out the obvious fractions. The only fractions you can make are denominator 1. Okay? And then the last one is natural numbers. And natural numbers is the same as whole numbers, except for natural numbers. For natural numbers, we start at 1. So we go to 1, 2, 3, 4, 5, and so on. Okay, so we basically start at 1, and then it's the same as whole numbers. So start at 1, then same as whole. All right. And once again, this abbreviation is N. If it's a whole number, the abbreviation is W. I think I already said that, but just to make sure. All right, so now let's map everything out one more time just so you can see it, and then I'll show you some examples, which this video may be a little longer than it should be, but you can skip through some of it if you want. All right, so here's what we end up doing. We have a real number, which is R. That breaks off into 2 separate branches. Okay, now one branch is irrational numbers, and that branch is essentially by itself. The other branch goes into rational numbers. Now, a rational number can also break down into 3 separate subsets. So we can have here, here, and here. Now, when those break off inside of rational, we have integers, which is z. Then a subset of that would be whole numbers. And then a subset of that would be natural numbers. Okay? Now, let's actually go through some examples so that you can see how we classify this. Because when you classify these, there can be more than one set per number. So like, let's say the number 30. And I'm asking you classify this. Okay, so classify it, determining which set it's in. So that means which set. And I want you to name all sets that it belongs to. Okay, so the number 30. All right, so first let's decide this. Is the number 30 a real number? Yeah, any number we see is a real number, so we'll write an R for that. So now let's go to the next notch. We have to decide, is it irrational? So remember, it branches off, real numbers branch off into two sections. We have to decide, okay, is this going to go into the irrational side or the rational side? And 30, you could write that as a fraction. You could say 30 over 1. So if it's written as a fraction, it's automatically an irrational number. So this is a rational number, which means it's going to get a Q. So let's go further. Now that we're in the Q side of things, we have to decide, okay, is 30 anything else that's also rational? So could it be an integer? So is 30 a negative or positive whole number? Yeah, it is. 30 is a whole number because the denominator is 1, so we could also say this is z. Now, could we say it's anything else? Let's see. So this z branch, or the integers, branches off into whole numbers, which means they're integers except they're only positive, but they start at 0. So does 30 fit into that? Yeah, because 30 is positive and it's bigger than 0, which, I mean, honestly, it doesn't even matter that it's bigger than 0. It's positive and it's a whole number, so there we go. All right, and then the last one is natural. Is 30 a natural number? Yeah, because natural numbers, it just starts at 1 and then goes from there. So essentially it's the same as whole number except it starts at 1. So this is actually every single thing except irrational. 30 is. Now, there could be a question that asks you this. It could say, what's the smallest set that this fits into? That would be natural numbers. But we'll worry about some of that later. Even if, I don't even know if we'll go over it in this video just because, I don't know, at this point it's probably redundant. All right, so let's do a couple more. Let's say we have, let's do negative 11. So you tell me, what are all the sets that negative 11 belongs to? Okay, so we'll say all sets. All right, so first thing we have to decide, is negative 11 a real number? Yeah, everything we see is going to be a real number. Okay, now, once again, we have to make the decision. Real numbers branch off into two separate directions, irrational and rational. So the biggest question is, can I write negative 11 as a fraction? Yeah, I could write it as negative 11 over 1. So negative 11 is going to be rational. Now, is negative 11 an integer? So is it positive or a negative whole number? Yeah, because once again, the biggest x, or the denominator here is 1, so this would also be an integer. Now, the next question is it a whole number? Remember, whole numbers start at 0, and they go from there, so we leave out the negatives. Therefore, it's not whole, which then means it can't be negative or natural. So these are my answers. And once again, the question could say, what's the smallest set that negative 11 belongs to? And you would just say integer, because that's the smallest one you could come up with. All right, let's find one that's a little bit different. Let's try to do this one. I warned you about this one, but let's see if we can actually do it. What about the square root of 21? Now, first question is it real? Is that a real number? Yeah, everything's a real number. Okay, well, that's not true, but everything that we're going to see right now is a real number. Then you have to decide, okay, Real branches off into two directions, irrational and rational. Which one does the square root of 21 fit into? Now, can we do the square root of 21 and get a whole number out? Or is 21 a perfect square? Meaning, can you take two numbers that are the same, multiply it to give you 21? No, you cannot. Square root of 20 could be done, it'd be 16. And then the next biggest one would be, or the next perfect square would be 25. So you can see when we go from 16 to 25, we skip over 21. So this is automatically irrational. And we're finished because a rational does not have any subsets. Let's do another one. I'm trying to give you a lot of these just so you can see examples. Let's say 6 over 3. Okay. Now, first of all, let's decide if it's real. Yeah, it's real. Is it rational or irrational? Well, it's a fraction, so it has to be rational. Now, could I simplify this? Could 6 over 3 simplify? Yeah, 6 divided by 3 is 2. So what we're actually trying to do is 2. So that means this is an integer. This is also a whole number, and it's a natural number. It's actually pretty much everything except irrational. All right, let's look at another one. What if I gave you pi? Now, if you put pi in the calculator, you're going to see it's going to give you a decimal, and that decimal is not going to stop. So, is it real? Yeah, it's real. Now, is it irrational or is it rational? Well, we said irrational numbers will never end. So this has to be irrational. And then we're finished. All right, I could give you several more. I mean, we could play this game all day. Let me give you just one more just to give you an idea. And then we will probably be finished with this one. All right, so let's go with 5.3, but those are bar over 3. So you have to remember what that bar means. It means repeating. So that should give away what our answer is, but let's list everything, okay, all the sets. Is it real? Yeah, it's real. Now, does repeating fit into rational or irrational? It fits into rational. I don't know what I'm saying. So, repeating fits into rational. Now, 5.3 is a decimal. Anything that's a decimal is not going to be integer, whole, or natural because those are all whole numbers that are not decimals. Okay, so this is actually where we would end, right here. All right, so once again, if I were you, I would use the tree to help me out, and I would say, okay, I have real branches off into two directions. All right, we have irrational, we have rational, and then rational has subsets, which means it has smaller levels to it. Okay, one of those levels is integer. The next lowest is whole. The lowest is natural. Okay, now that's your ticket to doing these, and you can ask more complicated questions from this, but this is just the quickest overview. So hopefully this makes sense. Reach out if you have questions, and that'll be it.